Hi there, this is going to be my third video about the bisection method. I already made the very first one in which I basically explained in step by step, in very detail, how this method works, and then I made the second one in which I basically show you another example. Now, this is the third one, and I'm basically going to show you a third example, a different one. So let's suppose we have our function 46x to the third plus 3x plus 1 equal to 0. So this is basically going to be our starting function, and this function is continuous, which is one of the requirements for the bisection method. The second requirement is that we gotta pick up 2 points, and those points have to be one positive and the other one negative. So our two starting points are going to be x1 equal to -4 and x2 equal to 1. So let's see the value in our 2 points. So -4. Well, let's just plug those value into our function. So -4 is actually going to be 46 times -4 to the third plus 3 times -4 plus 1. This is basically going to give us, well, 46 times -64 minus 12 plus 1. Okay, which is basically 2944 minus 12 plus 1, so -2955. Okay, so let's see our second, so our x2, so f of 1 is 46 times 1 to the cube, so 1 to the third, so 1 cube, plus 3 times 1 plus 1. So this is actually 46 times 1 plus 3 plus 1. And this is gonna give us 46 plus 3 plus 1, so 50. All right, so there we go. We have a positive value and a negative value. So this is precisely what we wanted. Let's draw our sketch for this function, as we always do. There we go. This is 0. Well, let's say that this is our value 1, and this other one is going to be, well, here, let's say -4. Okay, so at 1 we know that it's actually 50, so I don't know, let's throw it here. It's out of scale. I'm sorry, terribly sorry about that, but you know, you gotta do what you gotta do, and you're gonna live with your mistakes. Anyway, so a -4 is -2955. So this one is gonna be terribly out of scale as well. But you know, you gotta do what you gotta do. So -4 is actually gonna be here. So we have 2 points, +1 and -1, and the function is continuous. So it's pretty obvious, as I always say, and as I have said in the other videos, that is gonna cross the axis. So somewhere it's gonna go between here and here, and it's gonna cross the axis. All right. So our guess, let's say how it's going to behave between -4 and 1. So is basically our xr1 is going to be a -4 plus 1 over 2. It's going to give us -3 over 2, so -1.5. So -1.5 is basically the middle point between -4 and 1. So -1.5. Okay, so at -1.5, let's see how this function is going to behave. So we're basically going to plug in -1.5. So if we plug negative 1.5 into our function here, we basically get, well, 46 times negative 1.5 cube plus 3 times negative 1.5 plus 1, which is going to give us 46 times negative 3.37, negative minus 4.5 plus 1. Well, 46 times 3.37 is negative 155.02 minus 4.5 plus 1. This is negative 158.52. Well, this is still negative, and it's pretty negative. So, well, it's gonna be out of scale anyway. So let's say, well, so if I draw 50 here, let's say this is roughly here. So negative 158.52. So let's say that it's here at negative 1.5. It's roughly here. Okay, so still negative, and this point is positive, so we're now gonna find, try to find a point between negative 1.5 and 1, and see how the function is gonna behave. So our xr2 is gonna be negative 1.5 plus 1 over 2, so negative 0.25. So let's see that this is actually negative 0.25. And let's see, let's just plug negative 0.25 into our function. So f of negative 0.25 is actually going to be 46 times negative 0.25 cube plus 3 times negative 0.25 plus 1. This is going to give us 46 times 0.01 minus 0.75 plus 1. So this is 0.46 minus 0.75 plus 1. And this is going to give us, well, 0.71. Okay, so 0.71, so it's positive. So let's see, this is roughly here. So at 0.25 is going to be 0.71. So our best guess for this function is that it's going to go down like this. So it's going to be, you know, this kind of curve. And this is basically the bisection method. We could actually go on and try to find a value between 1.5 and negative 1.5 and negative 0.25 that is closer to 0. So we already found 0.71, which is pretty close to 0, but you know, we can get the better estimation and try to find where they're gonna cross the axis. So you know, you can basically see that the method is gonna converge, but of course you need the function to be continuous, and two starting points, one positive and one negative. Because you know, if you start with 2 positive points, there's no point in, you know, you're gonna find an approximation for 2 positive points or 2 negative points, but it doesn't really matter. What you want is to know where it's gonna cross the axis. So this is pretty much it. This is my last video about the bisection method. So if you want more video about this, feel free to ask. I'm gonna make them. But you know, it's a very simple method, so it's pretty straightforward, and I think that 3 videos are more than enough to explain it. Alright, as always, I hope it helps. Cheers and bye. Stay tuned.